Okay, so we're going to review Unit 8. So this is very similar to your first response. So here we go. You want to analyze the quadratic equation and graph the function below. Now, when you graph, I'm going to tell you now, if I do not see clearly defined points on your graph, you will not get the points. You must clearly define points on the graph and connect the dots the best that you can, creating as best of a U shape as you can. Now, this particular quadratic opens upward. Look at how the arrows are pointing upward. That is how I know that this quadratic opens up. The axis of symmetry cuts this parabola in half through the x value of -1. The vertex is this point, -1, -4. The y-intercept is where the parabola crosses the y-axis at 0, -3. Feel free to stop the video at any time, as I will be going quickly through this. Now, circle the graphs where the discriminant is positive. When the discriminant is positive, remember the quadratic formula. If you need to sing the song, sing the song. Okay? When this discriminant is positive, you are adding and subtracting a positive square root. That's a decimal. So you get 2 real roots. So when the discriminant is positive, you have 2 real roots. Here are your 2 real roots. Here you have 2 real roots. Here and here. For this one, your 2 real roots go through the x-axis. Place an x through the graphs where the discriminant is negative. If this discriminant is negative, you have imaginary or complex roots. Complex roots are when the quadratic does not touch the x-axis. So this is where the discriminant is negative. This is where the discriminant is negative because the quadratic does not touch the x-axis. Leave the graphs blank where the discriminant is 0. This is where you get one double repeated root, which we also call a root of multiplicity 2. Now, solve each equation using any method. Find exact solutions. This is where you can use any of the 4 methods that we've discussed. You can factor. You can use the square root method. You can complete the square. You can try the quadratic formula. If all fails, quadratic formula will never let you down. So, as long as you know the formula, you can use it on any one of these, as long as the quadratic is in standard form where the quadratic is set equal to 0. Now, in number 7, I decided to go by factoring to get the solutions. Remember to check these solutions by substituting them back into the original, making sure the left side equals the right side. In number 7, I get 2 roots, one at -7 and one at 2. What I would suggest you do is graph it and make sure that you get in the table -7, 0, and 2, 0. That will show the x-intercepts. In number 8, I use the square root method, and when you take the square root, you get 1 positive, 1 negative. Okay, that defines the square root method. The square root of a negative is I. The square root of 100 is 10. So therefore, you have 2 complex roots. You have 2 complex roots, one at positive 10i, the other at negative 10i. Number 9. This one, you can go by factoring. If it doesn't work, try something different. In this one, I decided to use the quadratic formula. So I use the quadratic formula and I get two real roots. They're decimals, keep this in mind, and you get them at -3/2 plus or minus the square root of 57 over 2. You can also write it as -3 plus the square root of 57 and -3 minus square root of 57, all divided by 2. These are all the same. Any of these would be acceptable answers. In number 10, I decide to complete the square. I bring that 6x over. I take half of the b term, which is 6. Half of that 6 is 3. Square it, add it to both sides, you get 9 on both sides. This creates a perfect square trinomial on the left, and you get 6 on the right. You take the square root of both sides, use the square root property, you get one positive answer, one negative answer. Add 3 to both sides, and you get x is equal to 3 plus the square root of 6. And the second root is 3 minus the square root of 6. Now, on the back, what I decided to do was set the quadratic equal to 0. I took out a GCF of x. I set both factors equal to 0, and I got these two zeros. One that goes through the origin, and one that goes through 7/4. Please do not put any answers in terms of decimals. I will mark you incorrect because any decimal answer is going to give you an approximation. The only time that's going to be acceptable is when you have to use it in a word problem. Now, number 12, I decided to factor it, and I got two factors, or two zeros, one at -1/3 and the other at 4. And number 13, I'm asking you to write the quadratic function in standard form with roots -4 and 2. So the factors are x plus 4 and x minus 2. You have to do FOIL, multiply the two binomials, you're going to get x squared plus 2x minus 8. 14, you have to give an example of a quadratic in standard form that has one real zero at 5. Well, if the parent function goes through 0 and it has one real zero at 0 because it goes through the origin, just slide it over to the right and it'll be moved over here. So if you slide it over, you need to subtract 5. And we discussed this transformation of sliding it horizontally to the right. You think the opposite, subtract. In number 15, here we've got a word problem. This is one of those situations where a decimal is okay. It's always going to be an approximation. So the height of a baseball after t seconds is being hit and gives us this function, -16t squared plus 48t plus 2. I want to know what's the maximum height of the baseball, and I want to know when that ball reaches the maximum height. So I need to find the vertex. The vertex's x value will give me the time, while the height of the vertex will give me the maximum height. That's the y value. So put it in context, after about 1.5 seconds, the baseball reaches a maximum height of 38 units. Now, I don't really have units for the height. It doesn't tell me meters, it doesn't tell me feet, it doesn't tell me yards, nothing. So we're going to say units, whatever that may be. In number 16, we have the length of a rectangle that's 6 inches longer than its width, and I know that the area of the rectangle is 40 square inches. I want to know what the dimensions are. So again, we're going to use what we know about area, which is length times width. If the length is 6 inches longer than the width, we're adding 6 to the width. So when I take these two, length times width, multiply them together, I get the total area of 40. When I distribute, I can then set this quadratic equal to 0, factor it, take out any extraneous solutions. If the width is a value of -10, think about it. What length is a negative number? We're going to exclude this value because length cannot be negative. So the only width that makes sense is going to be this 4. So if I substitute it back in, the width is 4. The length is 6 plus that width of 4. So 6 plus 4 is 10. So the dimensions are going to be 4 by 10 units. In this case, the units are going to be inches. Okay, number 17. I had to make a few changes. Okay. So 2 cars are leaving an intersection. One is traveling north. The other is going to be traveling west. Now, when the car traveling north has gone 24 miles, we're going to label it 24. The distance between the cars is 4 miles more than 3 times the distance traveled by the car heading west. We don't know how far he's traveling, but we know the distance between them is going to be 3 times his distance plus 4 more miles. Now, this is using what you know from geometry. Okay, you have essentially a right triangle. I want to know what is the distance between the 2 cars. So the easiest thing I can think of is to use Pythagorean theorem. Okay, if I square both legs, add them together, I get the hypotenuse squared. So what I can do is I can combine the 24 squared and the x squared, and I set it equal to the hypotenuse squared. Again, I had to multiply it out. Set everything equal to 0 and factor it. Any multiples can be excluded. I want to know what are going to be my values of x. Negative distance doesn't make sense. So when we factor this and we look for the zeros, negative 10 is going to be excluded. We're going to use 7. So I want to know what's the distance between the cars. Well, I need to substitute the 7 here. So 3 times 7 plus 4 is going to give me a total of 25 miles. That's the distance between the 2 cars. You need to be able to think more conceptually, more abstractly, using what you have learned. Do you have to use older concepts for this review? Yes. Okay. Is Pythagorean theorem obvious? If you look at and draw a picture, it is. If you don't draw a picture, it may not come to you. So follow my examples and go through your notes when you're studying. And I'll see you next time.